Good evening, ma'am.
Hariharan, your paper, the people who correct the paper. Hariharan, you are there?
Yes, ma'am.
Yeah, so your paper I couldn't correct. It is with me. I'll take a little time. Tonight I will correct it and I will send it to the learning room. You should be
Okay,
able to
ma'am.
get your marks by tomorrow. So I'm sorry for this delay.
It's okay, ma'am.
Good evening, ma'am.
Good evening. How are you?
Fine, ma'am.
So Vaishnavi, yesterday you were we were stuck on this page, and I couldn't give you a easy solution for this. So here you see how it has to be done. My camera. So you see when in the second order reaction, what is happening? What is the meaning of second order reaction? When you double the rate of reaction, when you double the concentration, the rate of reaction should become 4 times, right? And when you make it 3 times, the rate of reaction should become 9 times. So it is how many times? So you don't have to make 0.2 raised to 2. See, it is A raised to 2. A is the concentration. So when you make one, make it double, what you have to see is when you make the concentration double, then the rate of reaction should become 4 times. So when you make it 3 times, then the rate of reaction should become 3 squared times. 3 squared means 9 times. When you make it 4 times, then the rate of reaction should become 4 squared times. 4 squared times means 16 times. So if it is a second order reaction, I double it, the rate of reaction should become 0.8. When I make it 3 times, then rate of reaction should become 1.8. And when I make it 4 times, then the rate of reaction should become 3.2 times. 3.2 if I am comparing with the original. See what mistake yesterday you were thinking was that 0.2 has to be squared. It is not 0.2 that has to be squared, right? Because if I do 0.2 squared, then it will become 0.04. So 0.2 into 0.2 becomes 0.04. So the rate is not reducing, it is increasing, it is becoming double. So when it is becoming not double, but actually it is becoming 4 times. Okay, so that is what we have to understand here. So now
Yes,
we will
ma'am.
do a few more questions so that you become thorough with this. Okay, so let us do this question. My camera. So a reaction is found to be first order with respect to A and third order with respect to B. How will the rate of reaction change when the concentration of A is doubled and the concentration of B is halved? So we will do a few questions of this type. So a reaction is found to be the first order with respect to A and second order with respect to B. So there is a reaction which is where A plus B is giving me what? It is giving me the products. it is giving me the products. A plus B is giving products, right? Now, what is the rate of reaction? Rate of reaction, if I write, it is equal to K. It is first order with respect to A. So how will I write the rate law? K raised A raised to 1, and third order with respect to B. All right. Now I have what I have done. I have to find the new rate of reaction when I change the concentration. I double the concentration of A and I make the concentration of B half. So if this was A, initial concentration was A, then the new rate of reaction I have to find out where it is. Rate constant will remain the same because we are talking of the same reaction. A becomes 2A. Okay, what is the concentration has changed? It has become 2A, twice A. So it will be raised to 1, and B has become B by 2 raised to 3. B by 2 raised to 3. So now I have to compare how the rate will change. So this is equation number 1 and this is equation number 2, right? So how will I find the change? You divide 2 by 1. So if I divide 2 by 1, what will I get? I will get R1 by R is equal to K 2A raised to 1 and B by 2 raised to 3, right? Divided by K, A raised to 1 and B raised to 3. Okay, now this is arithmetic, you can do it. Now this and this will get cancelled. A raised to 1 and A raised to 1 will get cancelled. B raised to 3 and B raised to 3 will get cancelled. So what will I get? R1 by R is equal to 2 into 1 by 2 raised to 3. So 1 by 2 into 1 by 2 into 1 by 2. All right. So this will get cancelled. So R1 will be equal to R into 1 by 4. Okay, so what will the rate become? The new rate will be 1 by 4. It will decrease to 1 by 4 of the initial rate. Did you understand how I did the question? All of you, did you understand?
Yes, ma'am.
Vaishnavi, Vishal. Okay. Now, same way, let us do the next question. For a reaction NO2 plus Cl2 giving 2 NaCl is found that doubling the concentration of both reactants. Now, this is the other type. This is the opposite type. Now, I know. So, what is, I don't know the order of reaction. Now, I have to find the order of reaction. So, how will I do that? What is my reaction? R is, what is the rate law? The rate law is K NO raised to X and Cl2 raised to Y, right? I don't know what X and Y are. I have to find X and Y. But I know that if I double the concentration, okay, if I double the concentration of both reactants, the rate is increased by the factor of 8. So what it means is that if I make the concentration, say, initial concentration of this was A and this is B. So what did I do? I doubled. So this will become 2A raised to X. So initial concentration, what did I understand? Let me make the initial concentration of NO and Cl, A and B. So this is my initial concentration. Now A, 2A raised to X and 2B raised to Y is equal to 8R. The rate increases 8 times, right? So I have to find out what the value of X and Y is. Then the second equation says doubling the concentration of chlorine alone, the rate of reaction only doubles. So if I double the concentration, then K of chlorine alone, so A raised to X, and I only double the concentration of B raised to Y, it is 2R, it only becomes double. Okay, so this is equation number 1, this is equation number 2, and this is equation number 3. So if I divide 3 by 1, so you can choose what to divide. So if I divide 3 by 1, 3 divided by 1, then what will I get? 2R is equal to K, A raised to X, and 2B raised to Y. And divided by the first one, so R is equal to K, A raised to X, and B raised to Y. Right? So what will I get? R and R will get cancelled. K and K will get cancelled. AX and AX will get cancelled. And B raised to Y. This is 2 raised to Y into B raised to Y. So I will cancel B. Right? So what will I be left with? 2 is equal to 2 raised to Y. Okay, if 2 is equal to 2 raised to Y. So if 2 is equal to 2 raised to Y, what is Y equal to? Y is equal to 1. So what is the order with respect to B? It is 1. Now I have to do it with respect to A. I have to find with respect to A. So to find it with respect to A, I should have taken it on another page. I have to copy this. Just 1 minute. Start skipping. Okay, so the 3 equations are there. So now I have to find, I've already found Y is equal to 1. Now I have to find the value of A. So this time let me divide 2 by 1. Okay, so when I divide 2 by 1, what will I get? 8R is equal to K 2A raised to X and 2B. B raised to, I can just write 2B because now I know it is raised to 1. And then I can divide it by 1. So I am dividing 2 by 1. So R is equal to K A raised to X and B raised to 1. Okay. So now this R and R get cancelled, K and K get cancelled, A raised to X and A raised to X get cancelled. Right? So 8 is equal to 2 into 2, that is 4 raised to X. 4 raised to B and B get cancelled. So 2 raised to X into 2. So that is 4 raised to X. Okay. So what can I write? 4 raised to 2 here is equal to 4 raised to X. So X is equal to how much? X is equal to 2. So what is the order with respect to? So I can write order with respect to NO is equal to 2, and order with respect to Cl2 is equal to 1. So how will I write the rate law now? R is equal to K, NO raised to 1 and Cl2 raised to 2. That is the order of it. What is the overall order? Tell me, anyone? What will be the overall order? If you have understood what I am doing, what is the
3.
overall order? It will be
3.
3. 2 plus 1, that is equal to 3. Okay, so we have to practice a few questions of this type so that you understand well. There are some more questions. First, let us do those, then I'll come back to this. Okay. Now, a reaction is second order with respect to a reactant. How is the rate of reaction affected if the concentration of reactant is doubled and reduced to half? So what is my, if the reactant is say A, so what is the rate law? Rate law is K, second order, A raised to 2. Okay, second order reaction. So how is the rate affected if the concentration of the reactant is doubled? So if A becomes 2A, so what will be R1? R1 will be equal to K 2A raised to 2. Okay, so how will I find out what is, so I divided by R. R is equal to K A raised to 2, right? So R1 by R is equal to this and this get cancelled. A and A get cancelled. A squared get cancelled. So what is remaining? 2 raised to 2, 2 into 2. So R1 is equal to 4R. So if I double the concentration of the reactant, right? If I double the concentration of the reactant, the rate will become how many times? 4 times. That is a second order reaction. So I gave you other examples also. So what is the second order reaction? In that, if I double the concentration of the reactant, the rate becomes 4 times. This is a proof. Then if I reduce the concentration to half, now there is an easy way of doing it. So R is equal to, consider A as 1. So R is equal to K, that is the original 1 raised to 2. If it was 1, then now I half the concentration. So what will the new rate R1 become? Equal to K 1 by 2 raised to 2. So what will that become? It will be 1 by 2 into 1 by 2, it will be 1 by 4 times of the initial concentration. So R will become, R1 will become equal to 1 by 4 into R, right? 1 by 4 times. The new rate will become how much? 1 by 4 times. Okay, so whatever times you reduce it, you write there, you will get that. So that is, it is 1 by 4 of the initial rate of reaction. So that is how you are supposed to do these reactions. There may be 3 reactants, there may be 2 reactants, there may be only 1 reactant, but if you change the concentration, how will the rate of reaction change? That is how we do these questions. Okay, now this is one more. So the reaction is first order with respect to A and second order with respect to B. So what is the rate? Rate law, K is equal to A, and second order with respect to B, B raised to 2, right? How is the rate affected on increasing the concentration of B 3 times? So what will be the new rate? R1 will be equal to K, A, and B will become how many times? 3 times. So it will become 3B raised to 2. Okay. So if you find this method easier, then we will follow this method. This is 2. So I will divide 2 by 1. So it will be R is equal to K A B raised to 2. So this and this get cancelled, this and this get cancelled. So R1 by R is equal to B squared, and B squared will get cancelled. So what will I get? 3 squared. 3 into 3. So what is the new rate? R1 will be equal to 9 into R. Okay, so it will become 9 times the original rate. Did you understand why it became 9 times? Because the order of reaction was second order reaction. So when I increased 3 times, the rate increased by 9 times. Okay. How will the rate be affected when concentration of both A and B are doubled? So if both A and B are doubled, what will be the reaction now? R will be K 2A raised to 1 and 2B raised to 2. So how will I find out? This is R2. So this I divide by R, K, A and B. So K get cancelled, A get cancelled, and B raised to 2. So B squared and B squared get cancelled. So what am I left with? R2 by R is equal to 2 into 2 into 2. All right. So R2 will be equal to 8R. Okay, 2 into 2 into 2. Right? So that is one way of doing it. Now we can apply this to simple questions. There are questions where, okay, so that this is the initial rate method. This is a question based on which, experimental data is given, and we have to calculate the order of reaction and write the rate expression and find the rate constant. So how will I do that? Now there are these questions which are given to us. So in this data given below is for the reaction between NO and Cl2 to give NOCl, right? So what will be the equation? NO plus Cl2 giving NOCl. Okay. So this will be 2NO plus Cl2 giving 2NOCl. But anyway, the stoichiometric coefficients of this equation need not necessarily be the orders with respect to NO and Cl. So we have to figure out. So here what you see carefully, we will write the 3 reactions based on this. So the first equation is, concentration of chlorine and NO is given, right? So first equation is, our first one is 1.0 into 10 raised to minus 3 is equal to K into concentration of NO, so, and Cl2. So concentration of NO, let me write first because I've written it here first. So 0.05 raised to X, and this is 0.05 raised to Y. I don't know what X and Y are. The second, so this is equation number 1. Now second is 3.0 into 10 raised to minus 3 is equal to K concentration of NO, so that is 0.05 raised to X, and concentration of chlorine, so 0.15 raised to Y. So what do you observe by the second equation? That when I increase the rate of concentration of chlorine by 3 times, what happened to the rate of reaction? You can see that also became 3 times. Okay, that also became 3 times. Now let us write the third equation. What is the third equation? Third equation is 9.0 into 10 raised to minus 3 is equal to K into concentration of NO, that is 0.15 raised to X and 0.05 raised to Y. So this time I have kept the concentration of Y constant, but I have increased the concentration of this NO. I have increased it 3 times. So when I increased it 3 times, what happened to the concentration of uh, rate of reaction? It became 9 times. 9 times means 3 squared times. So 3 squared times means the concentration with respect to NO, the rate of order of reaction with NO appears to be how much? Appears to be second order. So my guess is that X is equal to 2 and Y is equal to 1. Now let us do it mathematically and prove it. So this is equation number 3. Now to do it mathematically, let us see how to do it. So what I'll do is first I will divide 2 by 1. 2 divided by 1. Okay, so I'll do 2 divided by 1. So when I do divide 2 by 1, what will I get? 3 by 1. This will become 3. So let me write here. 3 into 10 raised to minus 3 is equal to K into 0.05 raised to X and 0.15 raised to Y. And this divided by 1. So it will be 1 into 10 raised to minus 3 is equal to K 0.05, and this is 0.05 raised to Y, and this is raised to X. Now cancel K and K get cancelled, and 0 point, this 2 get cancelled, and this get cancelled, so it becomes 3 raised to Y, and this is 3. So 3 is equal to 3 raised to Y. So what is the value of Y? 3 raised to 1 is equal to 3 raised to Y. So Y is equal to 1. All right. Similarly, if I do the same thing with dividing 3 by 1. If I divide 3 by 1, what will I get? I will get 9 is equal to 3 raised to X. Okay, so I can say 3 raised to 2 is equal to 3 raised to X. So what will be the value of X? X will be equal to 2. Okay, so now I can change the rate law, and what can I write? R is equal to NO raised to 2 and Cl2 raised to 1. It is a chance that here the stoichiometric coefficients are the orders of the reaction. It's a simple reaction. So these are the orders of the reaction. Now you see here R is equal to NO raised to 2, Cl2 raised to 1. So order with respect to NO is 2, order with respect to chlorine is 1. Overall order of the reaction is 3. So we have got this answer. Order with respect to NO and chlorine 2 and 1. Write the rate expression. This is the rate expression. Calculate the rate constant. Now tell me whether you can calculate the rate constant. So let me make some space to calculate the rate constant. Okay, so I need to calculate the rate constant. Now this is K, I forgot to write. So how can I write the rate constant? Use any one of the equation. Let me use the first equation, 1.0 into 10 raised to minus 3, that is a rate is equal to K, 0.05 raised to 2 and 0.05 raised to 1. All right, so can I find K? K will be equal to 1.0 into 10 raised to minus 3 divided by 0.05 into 0.05 into 0.05. Right? So what will be the answer? Can you tell me? Can somebody tell me? Sai Kalyan, you are very quick with answers. Tell me. So 1.0 So 1, so it is 0.-3. So 0.001 divided by 0.05. What did you get? Will anyone, did anyone find the answer?
Ma'am, is it 8?
8. Answer is 8. Now 8, and now you have to write the unit. Okay, so what will be the unit? It is a third order reaction. So what will be the unit of K? It will be mole per liter 1 minus N. So 1 minus 3. S minus 1. So 1 minus 3 is how much? It is minus 2. So mole per liter raised to minus 2 and second minus 1. That will be the answer. Did you understand how to do this question, all of you? Now, next question I am not going to do. You have to do it. And I'll take 5 minutes, give you 5 minutes. Each one of you find the answer and tell me whether you got. I'll ask you separately. I'll ask each one separately. Okay, so this is the next question. It's a similar type of question. So for the following reaction, can you all see it or shall I make the font a little larger?
This is okay, ma'am.
Okay. Okay, now see. And tell me the answer, order of reaction with respect to NO and H2. If you can make out the order of reaction without doing it, nothing like it. Without doing the steps. You should be able to observe and see.
Ma'am,
So
is
when
it
I
first?
So see, when I double the concentration of A, right? When I double the concentration of A without changing the concentration of hydrogen, what is happening to the rate of reaction? How many times is the rate of reaction increasing? It is increasing. How many times? Can you tell me? 19.4 times. So if I double it, it increases 4 times, right? So what is the order of reaction?
Third order.
No. When I double it, this becomes 4 times. So how many times is it increasing? I increased the concentration double. So it has increased 4 times. So 4 times is what? 2 square times, right? So what is the order of reaction with respect here? It is 2. So it is second order with respect to NO. And when I keep the concentration of NO constant and double the concentration of hydrogen, right? What is happening? This is also becoming double. So when both are doubling, then what is the order of reaction? It is the first order. So it is first order with respect to hydrogen and second order with respect to NO. So how will I write the rate law? R will be equal to K, NO raised to 2 and H2 raised to 1. If orally you can't do it, then do the steps. But what you have to understand is, what am I doing? I am doubling the concentration here to here. What have I done? I've made it double. When I made it 2 times, this became how many times? 4 times, right? So what is the relation between 2 and 4? 2 raised to x is equal to 4. So what is 2 raised to x is equal to 2 raised to 2. So what is x? X is equal to 2. That way you can understand. So when I double the concentration, if it has become 4 times, that means it is a second order. In this case, what have I done? I have doubled the concentration, but the rate of reaction also became double. This is double and this is also double. So 2 raised to 1 is equal to 2 raised to 1. So it is first order reaction. Okay. So that is the rate law. Now can you find the rate value of rate constant? Choose any one of the reaction. Take the first one. So 4.8 into 10 raised to minus 3 is equal to K. Concentration of NO, that is 0.4 raised to 2, and H2 0.4 raised to 1. So what will be the value of K? K will be equal to 4.8 into 10 raised to minus 3 divided by 0.4, 0.4 into 0.4 into 0.4. So what will be the answer? Did you find the answer? Right? And this also will be moles per liter raised to minus 2 and second minus 1. Or you can write it as 0.075 liter square mole minus 2 and second minus 1. Did all of you get the answer? Hariharan, did you get the answer?
I'm doing.
Okay, do it. Hari Raghav, what about you?
Yes, ma'am, I got it.
Sanjay, what about you?
Yes, ma'am, got it, ma'am.
Vaishnavi, Sai
Yes,
Kalyan,
ma'am. Yes, ma'am. Got it.
Sai Kalyan, Sai Kalyan, I didn't hear you.
Got it, miss.
Got it, very good. Adhok Shajan. Adhok Shajan, are you there? I can't, oh, he is not, audio is not there only. Adhok Shajan, are you there? Please switch on your camera. Vishal, are you there?
Yes, ma'am.
Did you get the answer?
Yes, ma'am.
Okay, very good. Okay. Now just for practice, this is all typical one. Now this is from your textbook. Now all of you try to do this. Rate law and rate constant. Now this is a little complicated. Let me see how many of you can try. Sai Kalyan, I will ask you to explain these questions to everyone, so you please be ready.
Okay, miss.
Hmm. And you should all be able to do it by observation. Without writing the steps, you should be able to write the rate law. All of you are able to do it. Hariharan, are you able to do the question? Are you doing it? Hariharan? Sanjay, are you able to do it? Sanjay, are you there? Vaishnavi, are you able to do it?
Yes, ma'am.
Okay. Sanjay, where are you? Sanjay? Hari Raghav, are you able to do it?
I'm trying, miss.
Okay. And Hari Haran, are you able to do it? Hari Haran can't hear me. Vishal, what about you?
Yes, ma'am. Doing, ma'am.
Okay, very good. Very good. Now, Sai Kalyan will explain the question answer to everyone. Sai Kalyan, now explain. What will be the, how will I write the rate law? R is equal to, tell me Sai Kalyan.
Miss K
K
A to the power of 1, B to the power of 2.
A to the power of 1 and B to the power of 2. Right? Very good. Now, how did you find it? Tell me.
I divided the rate equations for any experiment.
Yes. So you see, if I take the first one and the fourth one. So in this, why did I choose first and fourth? Because in first and fourth, the concentration of B is constant. So keeping the concentration of B constant, I've increased the concentration of A 4 times. So when I increase the concentration of A 4 times, what happens to the rate of reaction from 6? It becomes 6 into 10 raised to minus 3, it becomes 2.4 into 10 raised to minus 2. So how many times it is increasing? It is increasing 4 times, right? Increasing 4 times. So when I increase this 4 times, the rate is also increasing 4 times. The order is 1. Now, if I take second and third, keeping the concentration of A constant, I am changing the concentration of B. So what did I do? I doubled the concentration. When I doubled the concentration, what is happening to the rate of reaction here? It is becoming 4 times, right? It is becoming 4 times. So since the rate of reaction is becoming 4 times, that means order with respect to B is 2. Okay, so you got it. Very good. Now, how will I find the rate constant? Choose any one of the reactions. So here it is 6 point, it is 6.0 into 10 raised to minus 3 is equal to K into A, that is A is 0.1 raised to 1 and 0.1 raised to 2. So what will be K equal to? K will be equal to 6.0 into 10 raised to minus 3 divided by 0.1 into 0.1 into 0.1. Right? So what will be the answer? Easy, isn't it? So it is 6. And what will be the unit? Mole per liter raised to 2 minus 2 and second raised to minus 1. Now all of you understood this type of questions. If you have, please tell me that. Then otherwise we can do a little more practice. I think rest you should do in the assignment. You should try to do in the assignment. Please copy and tell me if you have any doubts, then I can explain once again. Now children, I want to understand the next step of the reaction, next type of reaction, the next concept. I want to ask you, all of you have learned integration in school or not? Have you all learned integration in school?
Yes, ma'am.
Okay, so let me ask each one of you. Vaishnavi, have you learned integration?
Yes, ma'am.
And the Sai Kalyan, have you learned integration in school?
Yes, miss.
So all of you, anyone who has not learned integration, because you know, if you have all learned integration in school, it will be easy for me because I am very poor. My weakness is mathematics. I don't know maths well. So you all have to help me to get this part right. Okay. So what we have to now learn is, so what we have learned so far is we learned different types of rates. Average rate of reaction, rate of appearance and disappearance. We also learned uh, okay, that reminds me, there's one more question which I have kept for you all, which you have to do. Okay, we have to do this also before we do integrated rate law. Okay, so let us see how to do this reaction question. See, this question is also from your textbook. So this is using all the concepts that we have learned so far. Everything is put together. So for a reaction A, 2A plus B giving A to B, The rate law is K, A, and B squared. Value of K is given. Calculate the initial rate of reaction when A is 0.1 moles per liter and B is 0.2 moles per liter. So I have to calculate the rate. So what is the value? What is the rate law? The rate law is R is equal to K, concentration of A into concentration of B raised to 2. Right? First order with respect to A, second order with respect to B. And the value of K is given. So on substitution, what will I get? On substitution, what do I get here? I get R. I have to calculate the rate of reaction. So R is equal to K. What is the value of K? 2.0 into 10 raised to minus 6 into concentration of A, 0.1 mole per liter. And this is how much? 0.2. So this is 0.2 into 0.2. Okay. So what will be the rate equal to? Rate will be equal to, this is, so 2 into 2 into 2. So that is 8 into 10 raised to minus 9. Isn't it? 10 raised to minus 9. Did you understand how I did it? I just put the values. So 8 into 10 raised to minus 9. And what is the unit now remaining? If I just put all the units of each one here, I will get moles per liter per second. Okay. Anywhere unit for rate is always moles per liter per second. Now the next part of the question says calculate the rate of reaction after A is reduced to 0.06. So what has happened to rate A? A is reduced to 0.06. So now you have to look at the equation. So equation is, you have to do the first part, that what we did, giving A to B. Okay. So what has happened? 0.01. From 0.01, it has got reduced to how much? 0.06. Okay. So how much is consumed? How much has disappeared in this time? Rate of disappearance. So this is 0.4 has disappeared. This was 0.2. So when 0.2 moles per liter disappear for A, then how many moles of B will disappear in the same time? So it is, the ratio is 2:1. So when 2 moles disappear, here only 1 mole disappears. So when 0.04 moles disappear, then how many will disappear here? 0.02. Right? So this is at after disappearance, the rate of the concentration of A, what remains is 0.06. What is the concentration of B that will remain? It will be 0.2 minus 0.02, that will be 0.18. So this is the concentration based on which I have to now calculate my new rate of reaction. So what will be the rate of reaction when this has reduced? The rate constant does not change. So that will be 2.02 into 10 raised to minus 6 into 0.06 into 0.18 into 0.18. 0.06. Okay. So if I do multiplication here, what is the answer that I will get? 2 into, let us use the calculator. So 2 into 0.06 into 0.06 into, sorry. Who will find the answer quickly? So the answer, what I found with using a calculator, it is 3.89 into 10 raised to minus 9 moles per liter per second. Okay, so what do you see? When the rate of concentration of reactants has reduced, the rate of reaction also has come down. Okay, so sometimes the questions may be like this. So here you have to use the same rate law, but you may have to separately find the concentration of the reactants using the earlier knowledge that you have, that how will the concentration of the reactant change when this rate of appearance, rate of disappearance, keeping that in mind, you will have to do the calculation. So that's why I did this. So now we will do the these are some extra questions. So this I don't want to repeat. So now let me do the integrated rate law. So what I was telling you is that we have done average rate of reaction, we did instantaneous rate of reaction, we did the order of reaction, we did the rate law, we did the rate constant. Okay, so this many things we have done. Now what we do today is integrated rate law. Integrated rate law. Okay, so I told you in case of rate of reaction, what happens is that the rate is continuously changing, isn't it? Because as the concentration of the reactants is decreasing, the rate of reaction also decreases. So overall rate of reaction is, when we find between 2 points, we are only finding the average rate of reaction. We can calculate the rate of reaction at each instant and integrate all of them to get an integrated rate law or integrated rate of reaction, which will be more like the actual rate of reaction. So sometimes instead of just doing instantaneous and average rate, we can also find the integrated rate of reaction, and that is expressed in the terms of integrated rate law. So first, let us do it for the first order reaction. First order reaction. This is asked most frequently, so I am doing the first order first today, and then tomorrow we'll do the second order. So what is my reaction? A is changing into products. Okay, I am taking only those reactions where there's only one reactant taking part in the reaction and it is changing into products. So what will be, if it is a first order reaction, how will I write? R is equal to K, A raised to 1, right? That is first order reaction. Now, for this reaction, if I want to write instantaneous rate of reaction, then how will I write? R is equal to dA by dt minus dA by dt, because I'm writing in terms of rate in terms of A. So instantaneous rate in terms of A will be dA by dt. At that instant, small change in concentration of A divided by change in time. So R will be equal to dA by dt. So this is equation 1 and this is equation 2. So from A and 2, 1 and 2, what can I do? I can say minus dA by dt is equal to K into A. It is equal to K into A. Right? Now I can do, for my convenience, I can change it slightly and I can say minus dA by A is or I can change the sign also, take it on the other side. So I can say dA by A is equal to minus K dt. Can I do it? Tell me in terms of your integration. Okay, can I do this? Children, you all don't switch on your cameras. You don't answer. I really don't know how to. What is the problem? I don't understand. At least say yes or no, isn't it? So do you understand this expression, the last one that I wrote? Do you all understand this expression?
Yes, ma'am.
Okay, now I integrate it. So for integrating it, what I can do, I can write it in between limits of A0 and A and A0. The concentration of A at time when the beginning of the reaction, and A is the concentration after time t. So here I can do, and this side I will integrate it in the limits of 0 to t. So if I do this, what will I get? I can write it as ln A from A to A0 to A is equal to minus K T 0 to T. Okay, then I simplify it. What will I get? ln A minus ln A0 is equal to minus KT. All right. Now, in order to convert it into log, what can I do? I can write it as log A minus log A. I can say log A minus log A0 is equal to minus KT by 2.303. Right? Now I can change this again and I can say log A is equal to log A is equal to minus KT by 2.303 plus log of A0. Why I am doing all this? I am doing it to bring it to a particular format. What is the format? Y is equal to, I hope you understand all this. Y is equal to mx plus c. The graph, this is the equation for a straight line graph, right? So what will be the graph like? I'll take another page. First you copy, all of you. There is another way of doing it. You can do it by adding an integration constant also. So if you do that integration constant also, you will finally arrive at this equation only. Okay. Shall I go to the next page? All of you tell me if you are done.
Please, ma'am.
Okay. So now I want, so I'm writing this equation once again. Log A is equal to minus KT by 2.303 log of plus log of A0. So this is, I told you, is equal to y is equal to mx plus c. So when I compare it, if I draw, what does it mean? If I draw a graph, right, it will be a straight line graph, but it will be a negative slope. So y on x-axis, what on y-axis, what will I take? Log a, right? And on x-axis, what will I take? T. Okay, what is t here? Time. I will take t. Then there will be a negative, this line will be a straight line with a negative slope. Okay, straight line with a negative slope. And where the line comes and cuts the y-axis, that will be log A0. And the slope of this line will be what? The slope of this line will be minus k upon 2.303. That will be the slope of this line. Okay, so sometimes you may have to find a slope will be given and you may be asked to find the rate constant. How will you do? Slope is equal to, for a first order reaction, slope of the line is equal to minus k upon 2.303. Okay, so that is for the first order reaction. Now this equation, I can simplify it further. So in order to simplify this further, I can say log A is equal to, I can multiply the whole equation by 2.303. So what will I get? Log A. I have to simplify this equation. So this equation, I can bring this here. So minus, so this will become, if this equation, I can simplify it and write it as T is equal to 2.303 by K log of A0 by A. Where, what is A0? A0 is initial concentration. Concentration of the reactant. And A is equal to concentration of reactant after time t. After time is equal to t. After time t. And K is, of course, the rate constant. Rate constant. Okay. Did you all understand how this equation became this one?
Yes, ma'am.
Okay. So we have to understand this equation. Finally, you have to remember this equation. T is equal to 2.303 by K log of A0 by A. And then we have to do questions based on this. Okay. So let us do a few questions based on this, and then we will do one more concept. So the question is, which I have not typed and kept. So I will write down the question for you. So the question is that question based on this question is 75% of a first order reaction. First order reaction. 75% of a first order reaction was completed in 32 minutes. Okay. When was 50% of the reaction completed? how much time will it take for the 50% of the reaction to be completed? Okay, so how will I do this question? Okay, 75% of the first order reaction was completed. So what does it mean? Initial concentration was how much? If initial concentration was 100, right? 100, then what will be the final concentration? Final concentration, how much will be? Initial concentration, if it is 100, 75% of the reaction was completed. So what will be the final concentration? Final concentration will be 100 minus 75, that is equal to 25. Now you know this, so let us find the time we know. So let us find the rate constant first. So for the rate constant, T is equal to 2.303 by K log of A0 by A. A0 by A. So T is 32 minutes. 32 is equal to 2.303 by K log of A0 by A. So A0 is how much? 100 by 25. So that is log 4. Okay, log 4 is, these values will be given in the paper. So log 4 is equal to 6.6020. So K will be equal to 2.303 divided by 32 into 0.6020. So that will be equal to, so into 2.303 is equal to divided by 32. So you get 0.043, and this is per minute. Minute minus 1. Okay, so that is, you found the rate constant. Now, if you found the rate constant, now I can find the time for the second reaction, second part, how much time was required to complete 50% of the reaction. So how would I do that? Now you have to write again, T is equal to, in the same equation, I have to find T. T is equal to 2.303 divided by 0.043 into log of 50% completed. So that will be log of 100 divided by how much will remain if 50% is over? 50 will remain. So that will be log 2. Log 2 is equal to 0.3010. So it will be 2.303 into 0.043 into log 2. So log 2 is 0.3010. So what will be the time? So into 2.303 is equal to divided by so you will get 16 minutes. Did all of you understand what I'm trying to do? Yes or no, at least that much effort you can make, no, children? Hari Haran, Hari Raghav, Sai Kalyan, Vaishnavi. How
Yes,
many
ma'am.
times yeah,
Yes, ma'am.
Yes,
yeah,
ma'am.
good. Some effort you also have to put in, no? So that there's some communication. Now there is one more term that we need to know and understand, and that is called the half-life of a reaction. So to do the half-life of a reaction, that's the next thing that we will learn now. So calculating half-life of first order reaction. Okay, what is the meaning of half-life? Half-life is time required to uh, time required when concentration of the reactants becomes half. Okay, that is called half-life, when the concentration of the reactants become half. So what is my equation? T is equal to 2.303 by K log of A0 by A. So what to find half-life, how will I calculate T half is equal to 2.303 by K log of A0, that is the initial concentration, when the final concentration becomes half of the initial concentration. So that is, it becomes A0 by 2. So what will T half be equal to? It will be equal to 2.303 by K log 2. And log 2 is, I just now told you, it is equal to 2.303 by K into 0.3010. And that comes equal to T half is equal to 0.693 by K. So this is a important equation. So sometimes when you are given the initial concentration and you have to just find what is the your half-life, you have to just divide it by the rate constant, 693 by rate constant. That will give you the half-life. Now here you can see in the formula for half-life, the initial concentration does not come into picture. Okay, so half-life is just dependent on the rate constant. It doesn't matter how much is the initial concentration. The other thing which you should understand is that, most of the nuclear reactions, they are dependent on, they are all first order reactions. And they are the reactions where your, half-life makes a lot of difference. I want to give you one interesting example. It's not here. Let me do one or two questions from your textbook. Control M. So the question is, calculate half-life. Calculate half-life of the following First order reactions. First order reactions. Okay, so first question is one, the rate constant K is equal to 200 second minus 1, because first order reaction K will be second minus 1. So for this reaction, I have to find out the half-life. So how will I find the half-life? T half is equal to 2.303 by 200 by K, isn't it? By K. So that will be equal to 2.303 divided by 200 per second. So that will come to 2.303 divided by 200. So I'll get 0.0115. Okay, that will be in seconds. Okay, so depending on the value of K, you can find out there is another one in 4 years. K is equal to 4 years minus 1. So the K value can also be in years. So T half will also come in years. So T half will be equal to 2.303 by K, that is equal to 2.303 divided by 4. So that will be equal to how much? 2.303 divided by 4. So it is equal to 0.575 years. Okay, answer will be in years. So, you know, all this radioactive decay and all, they follow first order reaction. So, in Hiroshima and Nagasaki, the nuclear bomb was dropped in 1948. But even now, there is some remnants of the radioactivity is still there. So, why is it so? So say, for example, I start, what is the real meaning of half-life? So it means that supposing I started with 100 grams of a substance, and the half-life of, it's a radioactive substance. So its half-life is, say, 10 years. What is the meaning of that? The meaning of that is that after 10 years, the concentration, the amount of 50% of this will remain. So after 10 years, how much of the substance will remain? It will be 50 grams. Okay. Then after half-life is 10 years, after another 10 years, how much will remain? 50% of this. It doesn't matter how much it was there initially. Again, this will become the starting point. So how many? 25
20.
grams. And then after another 10 years, how
12.5
much?
grams, ma'am.
12.5 grams will remain. And after another 10 years, it will become
7.25. 25, ma'am.
6.25 grams. And then it will keep on slowly decreasing. So you can imagine that after 10, 20, 30, 40 years, also 6.5 grams. It will take lots of time to completely disappear because it's half-life. It will every 10 years, it will become half of the concentration at the time. So every 20 years, it will become half. Okay, so then it will become half of this. So it will become 3.75, then half of this, then 1 point something, and then again 0.05. So it will take millions of years for it to completely disappear. So that is the real meaning of half-life, the time required when the initial concentration will become 50%. So If half-life is 10 years, that means in 10 years, 100 grams will change to 50. Another 10 years, 50 will change to 25. And this is how the nuclear reactions or the radioactive decay, it follows the first order kinetics. First order kinetics means half-life is independent of initial concentration. It will half-life only means how much time it will require for initial to change into 50%. Okay. So that is about first order reaction. Now, tomorrow also we have a class, and in that class we will do similar questions, but we are going to use the same technique for finding what happens for a zero order reaction. So in first order reaction, you have to always remember the graph is always a slope, which is a negative slope. And when you draw a graph between time and the log of the concentration, log A, then what you get is a negative slope, and the slope of this reaction of this graph, that is, it will be minus K by 2.30, negative slope. So slope will be minus K by 2.303. So if I find the slope of the reaction also, I can find the rate constant. So I have not done that type of question now. So I will keep those questions ready for tomorrow, and then we can do those questions tomorrow. Okay, so now I want to see you all one by one. So,
Ma'am, can you show me the 46th slide, ma'am?
46th slide, yes.
Yes, ma'am. Thank you.
Okay. So all of you understood what I taught today. Now we
Yes,
will
ma'am.
do. Yeah, very good. Okay, so please revise and look in the textbook and try to do more questions from there. I have done quite a few, but you do, and hopefully tomorrow we should be on. But there is, let's see if you can finish the topic tomorrow. But I may need one more class after half a class. Okay, then see you. Bye.
Thank you, ma'am.
You're welcome.
Thank you.
Thank you, ma'am.